Well, this is the last video on center of mass. We just have a couple of problems here for the center of mass of a figure between two curves, and I'll go over problems 2 and 4 on here. We've got the formulas for the center of mass of a space between two curves. Let's see. So, problem 2, we start out with y equals x squared minus 3 and y equals negative 2x squared. So again, I encourage you to use the graphing calculator to take a look at these. These are not too taxing in this case. X squared minus 3 is just going to be the x squared parabola moved down here to have the vertex at negative 3. Or 0, negative 3. And then the y equals negative 2x squared is going to be a little bit skinnier than usual because of that 2, and it's going to be upside down because of the negative. Okay? And then these intersection points right here, you can set these equal to each other and solve, or you can use the calculator, but these should be negative 1 and positive 1, right? Because 1 minus 3 is negative 2. 1 times negative 2 is negative 2, and the same thing will happen for negative 1. So there's negative 1, and there's positive 1. So first, let's find the area. So our area runs from negative 1 to positive 1. We've got the negative 2x squared on top, and then that x squared minus 3 on the bottom. So minus x squared minus 3. So this will be negative 2x squared minus 1x squared plus 3. So negative 3x squared plus 3, or negative x cubed plus 3x from negative 1 to positive 1 plus 3 minus this will be negative 1, and then minus 3. So that'll be plus, and then this will make it minus again. And this is that doubling that you frequently see in things that are symmetric about the y-axis. And so this ends up being 6 minus 2, which is 4. Okay, so we've got an area of 4. And now we'll go and calculate x bar and y bar. And again, for this thing that is symmetric about the y-axis, our x bar is going to be 0. I'll go ahead and calculate it, okay? But we should see that we get a value of 0 for x bar. So let's put that in there. Let's go ahead and do the calculation here. So this will be 1 over 4 from negative 1 to positive 1. X times the f function is the negative 2x, and then the g function is that x squared minus 3. So again, it's minus parentheses x squared minus 3. So let's see what we get here. So this is going to be negative 3x squared. So that'll be negative 3x cubed. And then this is just a 3 times x makes 3x. So if we integrate, let's see, negative 3/4 x to the 4th plus 3/2 x squared from negative 1 to positive 1. So let's see, negative 3/4 plus 3/2, that's for the positive 1. And then the negative 1, because these are even powers, we're also going to get negative 3/4 plus 3/2. So this will be plus 3/4 minus 3/2, and that will cancel these out exactly. And that gives us x bar equal to 0. Okay. The y bar is going to be a little bit more interesting. So let's see what we get there. Okay. We got the same 1 over a. Oh, and then we're going to need that 1/2, right? Same limits of integration. Now we need f squared So negative 2x squared all squared, and then minus x squared minus 3 all squared. So that's going to be a positive 4x to the fourth, and then minus x to the fourth minus 6x squared plus 9. Let's see, so that'll be 3x to the fourth, and then plus 6x squared minus 9. And now we can integrate. So that's 3/5 x to the fifth, 6 over 3 x to the third, minus 9x, excuse me, from negative 1 up to positive 1. Okay, so let's see what we get here. 1/8. And then 3/5 plus 2 minus 9, that's for the positive one. And then the negative one, that's going to be negative 3/5 minus 2 plus 9. And so that's just going to double all of these that we had originally. So 6/5 plus 4 minus 18. So let's see. This is 6/5 minus 14, and so that is negative 64 over 5, right? Because this is 70 over 5, so 6 minus 70 will give us the negative 64. Those cancel, and there's our negative 1.6 for the y-bar. And let's see, so if this is 3, it's going to be a little more than halfway, right? Because if something's symmetrical, it'll be exactly halfway, but you can see this really isn't symmetrical, right? This is there's more of the area is down here than it is up there because this thing is open wider, okay? All right, so that's problem 2. Let's take a look at problem 4. Let's see, let's erase those. All right, so problem 4, we've got 1 minus x squared and 1 minus x. And again, you can graph these on the graphing calculator. What you're going to see is something like that. Okay, this is kind of a sliver piece. And these are both intersecting there at positive 1, and then that point right there is 0. Okay, so first off, let's find the area for this region inside there. So that's going to be the integral from 0 to 1. What's on top is the parabola, and then underneath it is the linear piece, minus 1 plus x. So those cancel each other out, and this is the integral of x minus x squared. So that's x squared over 2 minus x cubed over 3 from 0 to 1. So a half minus a third, and then minus 0. And so this is 3/6 minus 2/6, and so our area is 1/6. Okay, so that was pretty straightforward. Now we want to do x bar, so that'll be 6 times integral from 0 to 1, x times f minus g. Okay, so again, 1 minus x squared minus 1 plus x. So this is going to be, let's see, this x times this x will be a positive x squared, and then this negative x squared times x will be negative x cubed. And now we can integrate x cubed over 3 minus x to the fourth over 4 from 0 to 1. A third minus a fourth, and then minus 0. So this is going to be 6 times the 12th, and so x bar should be 0.5. So this is exactly halfway between those endpoints on the x coordinate. And I guess that makes sense. It seems like the area is pretty evenly split in between those two halves. So x bar is 0.5. Okay, let's go back and find y bar. Let's see here. So y bar, then we're going to have the half here, and then the f squared, 1 minus x squared all squared, and then 1 minus x all squared. Okay, so now this is 3, and this is 1 minus 2x squared plus x to the 4th, and this is 1 minus 2x plus x squared. All right, so the 1's cancel each other out again. So, before we integrate, we've got this 2x, and then minus 2x squared minus 1x squared, so minus 3x squared, and then the x to the 4th, positive x to the 4th. Okay. So let's integrate. That'll be x squared minus x cubed plus x to the 5th over 5 from 0 to 1. All right, so that's going to be 1 minus 1 plus a 5th, and then minus 0. So these cancel each other out, and this is just 3/5, or 0.6. All right. And this is the 0.1, there's 0.5, so 0.6 is right in about, whoop. And then I'm just going to put it right there. It's hard to say whether or not my drawing, how accurate the drawing is. But in any event, it looks like our x bar and y bar should be at 0.5 and 0.6. Okay, problem 5 on here is just kind of one of those fun problems. It's a little bit tricky. You've got irrational limits of integration, but there's only 3 odd problems on here, so it shouldn't be too bad. And this is the last assignment before the midterm, okay? So I'm in the process of getting the take-home midterm ready to mail out to everybody, and I will talk more about that in the next couple of days.